Hello, and welcome to another journey through the unknown. Tonight, we're stepping into the quiet spaces between what we know and what we don't. The regions where science meets mystery, where observation ends and wonder begins. Space is not what most people imagine. It is not a solved puzzle, neatly arranged in textbooks with every question answered. It is vast, yes, ancient, certainly, but more than anything, it is filled with things we cannot yet explain. There are sounds we've detected that have no source, structures so large they shouldn't exist according to our models, objects moving in ways that defy our understanding of physics, and throughout it all, a persistent, quiet hum of mysteries that astronomers encounter, document, and then wait, because some questions don't have answers yet. Some puzzles remain unsolved, not because we haven't looked, but because the universe itself seems to be withholding its secrets, showing us just enough to know something is there, but not enough to understand what it truly is. This is not a flaw in our science. It is the nature of discovery. Every answer we find reveals 3 new questions. Every mystery we solve opens a door to 10 more mysteries waiting behind it. And tonight, we're going to move through some of these quietly. Not to solve them, but simply to acknowledge them. To sit with the unknowns. To let them wash over us like waves on a dark shore. There is something deeply calming about unsolved mysteries. They remind us that the universe is larger than our current understanding, that there is always more to discover, that the story is not finished. You don't need to remember everything you hear tonight. You don't need to follow every detail or hold on to every concept. This is not a test. There will be no questions at the end. This is simply a slow walk through the unanswered corners of space, a gentle tour of the things we've found but cannot yet explain. If you find value in this kind of content, if these slow explorations help you rest or give your mind a place to settle, you're welcome to like this video, to subscribe, or simply to leave a thought in the comments about which mysteries intrigue you most. It helps others find their way here too, but there's no pressure, no urgency, just an invitation if it feels right. For now, you can let yourself settle. Let your breathing find its natural rhythm. Let the weight of the day begin to drain away. We're going to move slowly tonight, from the edges of the observable universe inward, from the largest mysteries to the smallest, from the cosmic to the quantum. And throughout, we'll maintain this same gentle pace. A pace that asks nothing of you. A pace that allows you to drift whenever your body is ready. Because the mysteries of space have been waiting for billions of years. They can wait through your sleep too. They'll still be there tomorrow, still unanswered, still patient, still quietly calling to those who wonder. So take a breath. Let your shoulders soften. Let your thoughts begin to slow. The universe is vast and strange and beautiful. And tonight, we're going to explore the parts of it that remain, even to science, deeply and profoundly mysterious. Let's begin. There is a sound in space that no one can explain. In 1977, a radio telescope in Ohio detected something unusual. A signal, strong, clear, lasting for 72 seconds. It came from the direction of the constellation Sagittarius, and it was unlike anything researchers had heard before or since. The astronomer on duty, seeing the printout, circled the sequence, and wrote one word in the margin: "Wow." The wow signal, as it came to be known, has never been explained. It matched no known natural phenomenon. It appeared once and never repeated. Decades of listening to that same region of space have yielded only silence. Was it a message? A natural event we don't understand? A glitch in the equipment? We don't know. This is not unusual. Space is full of signals we cannot explain. Bursts of radio waves lasting only milliseconds. Patterns that seem too regular to be random. Emissions from regions of space where nothing visible exists. Each one is documented, studied, analyzed, and then filed away in the growing catalog of things we've detected but cannot interpret. The universe is speaking. We can hear it, but we cannot yet understand the language. And perhaps that's fitting, because space has always been a place of mystery. Even before telescopes, humans looked up and wondered what the lights were, where they came from, whether we were alone. We have answered some of those questions. We know now that stars are distant suns, that planets orbit them, that galaxies stretch away in every direction, islands of light in an ocean of darkness. But the deeper we look, the more mysteries we find. The more we discover that what we thought we knew was only the beginning of a much larger, much stranger story. There are objects in space called fast radio bursts. They flash across the cosmos in the blink of an eye, releasing as much energy as the sun produces in an entire day. And they do this in just a few milliseconds. We've detected hundreds of them. They come from distant galaxies. Some repeat, some don't. And we have no consensus on what causes them. Perhaps they are the dying breaths of massive stars. Perhaps they are signals from magnetars, neutron stars with magnetic fields so strong they warp the very fabric of space. Perhaps they are something else entirely, something we haven't imagined yet. The data arrives, the telescopes record, the computers process, and scientists around the world look at the results and say quietly, "We don't know." This is not failure. This is the frontier. This is where science lives, in the space between the known and the unknown, building bridges of understanding one careful observation at a time. And some bridges take longer to build than others. There is a structure in space called the Great Wall. It is a vast filament of galaxies, stretching across more than 500 million light-years of space. For context, our entire observable universe is only about 93 billion light-years across. The Great Wall shouldn't exist. According to our understanding of cosmic evolution, there hasn't been enough time since the Big Bang for gravity to pull matter into structures this large. And yet, there it is, visible in our surveys, undeniable, a wall of galaxies defying our models of how the universe grows and changes. It is not alone. We've found other structures. The Sloan Great Wall, the Hercules Corona Borealis Great Wall, even larger, stretching across 10 billion light-years. These are not small anomalies. They are fundamental challenges to our understanding of cosmic structure formation. How did they form? Why are they so large? What does their existence tell us about the early universe? These questions remain open. The structures exist. The measurements are clear. But the explanation, the mechanism, the deeper understanding is still being sought. Space does not give up its secrets easily. It requires patience, careful observation. The willingness to sit with uncertainty for years, sometimes decades, while data accumulates and theories are tested and refined. And sometimes, even after all that, the answer remains just out of reach. A whisper in the data, a suggestion of something deeper that we're not quite ready to see. You can let your mind rest with that thought. There is no urgency here, no need to solve anything. We're simply observing, simply acknowledging what is unknown. The mysteries of space are not problems that demand immediate solutions. They are invitations, gentle reminders that reality is larger, stranger, and more wonderful than any single explanation can capture. And tonight, as you settle into rest, you can carry that with you. The knowledge that somewhere out there, in the vast darkness between galaxies, mysteries are waiting. Patient, timeless, content to remain unsolved until the universe itself decides to reveal them. Take a slow breath. Let it out gently. Let the day fade. We're going to continue now, moving deeper into space, exploring more of these quiet unknowns. And as we do, you're welcome to drift, to let the words become a gentle background, to allow sleep to arrive whenever it's ready. Because these mysteries have waited billions of years, they can wait through your rest too. There is something at the center of our galaxy that we cannot see directly, but we know it's there because of what it does to everything around it. Sagittarius A star, a supermassive black hole, 4 million times the mass of our Sun, compressed into a space smaller than Mercury's orbit, and it sits there at the heart of the Milky Way, pulling on stars, warping space-time, drawing matter toward itself in a slow, inevitable spiral. We can track the stars that orbit it. Some have been observed for decades, following elliptical paths that bring them so close to the black hole they reach speeds of nearly 5% the speed of light. These stars tell us the black hole is there. Their motions prove its existence, as clearly as ripples prove the stone that disturbed still water. But the black hole itself remains invisible, not because our telescopes are inadequate, but because that is what black holes are. Regions where gravity is so intense that not even light can escape, where space-time curves so severely that it closes in on itself. What happens inside a black hole? What exists at the center, in that point of infinite density we call a singularity? We don't know. Our mathematics breaks down there. The equations that describe gravity and space-time, usually so reliable, return infinities, meaningless numbers, signs that we're missing something fundamental. Perhaps the singularity is not truly infinite. Perhaps at the smallest scales, quantum effects step in to prevent the collapse from continuing forever. Perhaps something entirely new happens, something we have no framework yet to understand. Or perhaps the singularity is exactly what our mathematics suggests, a place where the normal rules of physics cease to apply, where time and space lose their meaning, where reality itself becomes something alien. We cannot see inside to know. The event horizon, that boundary around the black hole where escape becomes impossible, shields the interior absolutely. No signal can cross from inside to outside. No information can leak out. What we can study is the boundary itself. The region just outside the event horizon, where matter piles up, heats up, releases energy in great spiraling torrents, before finally crossing the point of no return. And even here, mysteries abound. Black holes are not simply vacuum cleaners, mindlessly consuming everything nearby. They shape their surroundings. They launch jets of particles at near light speed, perpendicular to their accretion disks. These jets can extend for thousands of light years, far beyond the galaxy itself. How do black holes create these jets? The details remain unclear. Magnetic fields are involved. The spinning of the black hole plays a role, but the exact mechanism, the precise physics that accelerates particles to such incredible energies, is still being worked out. Some black holes are quiet. They sit dormant, barely feeding, like Sagittarius A star at the center of our galaxy. Others are ravenous, consuming the equivalent of several Earths per second, blazing so brightly they outshine entire galaxies. What determines whether a black hole is active or quiet? Why do some feed aggressively while others hardly eat at all? These questions connect to the larger mystery of how galaxies evolve, how black holes grow, how the two shape each other over billions of years. And then there is the question that puzzles physicists most deeply. What happens to information that falls into a black hole? In physics, information is not supposed to be destroyed. It can be transformed, scattered, hidden in complex ways, but never truly erased. This principle, the conservation of information, is fundamental to quantum mechanics. But black holes seem to violate it. When matter falls past the event horizon, all information about it, its composition, its history, its quantum state, appears to be lost forever, gone, erased from the universe. This creates a paradox, the black hole information paradox, and it has troubled physicists for decades. Stephen Hawking proposed that black holes might not be entirely black. Through quantum effects at the event horizon, they should slowly evaporate, releasing faint radiation. Over unimaginably long timescales, a black hole could shrink and eventually vanish completely. But if the black hole evaporates, and if the radiation it releases carries no information about what fell in, then information has been destroyed. The universe has forgotten. Various solutions have been proposed. Perhaps the information is encoded subtly in the Hawking radiation, scrambled beyond recognition but technically present. Perhaps it's stored on the event horizon itself, written into the surface in ways we don't yet understand. Perhaps black holes are connected to other regions of space-time, wormholes through which information could escape. None of these ideas are proven. The paradox remains open, a puzzle sitting at the intersection of quantum mechanics and gravity, two of our most successful theories refusing to fit together cleanly. And beyond the information paradox lies an even deeper question. Are black holes doorways? Some solutions to Einstein's equations suggest that black holes might connect to other regions of space, or to other times, or even to other universes entirely. These solutions describe wormholes, tunnels through space-time, with a black hole at one end and a white hole, a hypothetical region where matter and light emerge at the other. But these are mathematical possibilities, not confirmed realities. Wormholes, if they exist at all, would likely be unstable. They would collapse before anything could pass through. And even if they could be stabilized, the tidal forces near the event horizon would tear apart any object that tried to enter. Still, the mathematics allows them. And in science, what the mathematics allows nature sometimes provides. So the question remains open, waiting for observations that might someday reveal whether black holes are indeed bridges to elsewhere. For now, black holes remain among the most mysterious objects in the universe. We know they exist. We can see their effects. We can measure their masses and spins. But their interiors, their ultimate fate, and their deepest nature remain hidden behind horizons we cannot cross. You can rest with that image. Black holes, silent, patient, holding secrets in the dark. There is no need to understand them fully tonight. No need to solve the paradoxes they present. They are simply there. Part of the vast tapestry of space. Part of the mystery. Let your breathing continue its slow rhythm. Let your thoughts soften. We're going to move now to another mystery, another corner of space where our understanding reaches its limit and then stops, gazing into uncertainty. There is something pushing the universe apart, and we have no idea what it is. In the 1990s, astronomers were studying distant supernovae, explosions of stars so bright they can be seen across billions of light years. These supernovae are remarkably consistent. They always reach roughly the same peak brightness. This makes them useful as cosmic distance markers. If you know how bright a supernova truly is, and you measure how bright it appears from Earth, you can calculate how far away it is. The astronomers were trying to measure the expansion of the universe. They expected to find that the expansion was slowing down. Gravity, after all, should be pulling galaxies back together, gradually breaking the outward motion that began with the Big Bang. But that's not what they found. Instead, they discovered that the expansion is speeding up. Galaxies are accelerating away from each other. The universe is not just expanding, it is expanding faster and faster over time. This was so unexpected, so contrary to predictions, that the teams checked their work repeatedly. They analyzed the data in every possible way. They looked for errors, for biases, for anything that might explain the result without requiring something new and unknown. But the result held. The universe is accelerating, and something must be pushing it. We call that something dark energy. Not because it's dark in the sense of being shadowy or evil, but because we can't see it. It doesn't emit light. It doesn't absorb light. It doesn't interact with matter in any way we can detect directly. All we can observe is its effect, a gentle, constant pressure filling all of space, pushing galaxies apart. Dark energy makes up about 68% of the universe. More than 2/3 of everything that exists is this mysterious energy we cannot see, cannot touch, cannot directly measure. What is it? We don't know. One possibility is that dark energy is a property of space itself. That empty space has a tiny, inherent energy, and as the universe expands, more space is created, which means more energy, which drives further expansion. This is called the cosmological constant, and it fits the observations reasonably well. But it raises as many questions as it answers. Why should empty space have energy? Why should that energy have exactly the value it does, neither stronger nor weaker? The value of the cosmological constant is fantastically small, and yet perfectly tuned to allow the universe to exist as we see it. If dark energy were even slightly stronger, galaxies would never have formed. Matter would have been pushed apart before gravity could pull it together into stars and planets. If it were much weaker, the universe might have collapsed back on itself long ago. So we're left with a mystery, an energy that permeates all of space, an energy that determines the fate of the universe, an energy we cannot explain. And dark energy is not the only invisible component of the cosmos. There is also dark matter, another unseen presence, making up about 27% of the universe. Dark matter doesn't emit light, doesn't absorb light, but it has mass, it has gravity, and it holds galaxies together. When astronomers measure how fast stars orbit within galaxies, they find something strange. The stars at the edges move too quickly. According to the visible matter alone, those outer stars should drift away into space. The galaxy shouldn't hold together, but it does, because there's more mass there than we can see. A halo of invisible matter surrounding each galaxy, providing the extra gravity needed to keep everything bound. We know dark matter exists because we can see its gravitational effects. Galaxies cluster in ways that require more mass than the visible stars and gas provide. Light from distant galaxies bends as it passes through regions of space, bent by gravity, by mass, even though nothing visible is there. Dark matter shapes the large-scale structure of the universe. It forms a cosmic web, filaments and nodes where galaxies gather, connected by invisible threads of dark matter spanning millions of light years. But what is it made of? We don't know. It's not ordinary matter, protons and neutrons and electrons. We've looked for dark clouds of regular atoms, and they're not there in sufficient quantities. Dark matter must be something else, something that interacts with gravity, but almost nothing else. Physicists have proposed various candidates, exotic particles, never seen in laboratories, that formed in the early universe and have been drifting through space ever since. WIMPs, weakly interacting massive particles. Axions, ultralight particles predicted by certain theories but never detected. Primordial black holes, tiny black holes formed in the first moments after the Big Bang. Experiments search for these particles. Detectors buried deep underground wait for a dark matter particle to collide with an atom. Particle accelerators try to create dark matter in collisions. Telescopes look for indirect signs, gamma rays or other radiation that dark matter might produce when particles meet and annihilate. So far, nothing definitive, only limits, only the growing certainty that if dark matter is made of particles, they are incredibly elusive. And so the mystery deepens. We live in a universe where 95% of the content is invisible to us. Dark matter and dark energy dominate the cosmos, shaping everything we see, and yet we understand almost nothing about them. The stars, the planets, the galaxies, all the ordinary matter we can see and touch amounts to less than 5% of what exists. We are a small minority in a universe dominated by the unseen. This is humbling, and in a way, it's also calming, to know that reality is so much larger than our immediate perception, that the universe holds depths we're only beginning to glimpse. You don't need to grasp all of this tonight. You don't need to hold on to these concepts. They are simply here, part of the landscape we're moving through. Mysteries among many mysteries. Let your body settle more deeply now. Let your muscles release whatever tension they've been holding. Let the darkness behind your closed eyes mirror the darkness of space, vast and calm, and filled with hidden presence. we're going to continue moving through these mysteries, slowly, gently, and as we do, you can allow yourself to drift further, to let the words become background, to find whatever rest you need. The universe is patient. The mysteries are patient. And tonight, you can be patient with yourself, too. There is a hum in the universe that no one expected to find. In 2015, scientists detected gravitational waves for the first time, ripples in space-time itself, caused by two black holes colliding more than 1 billion light-years away. The waves traveled across the universe, stretching and squeezing space by less than the width of a proton, until they reached Earth and were captured by exquisitely sensitive detectors. This was a triumph, a confirmation of Einstein's predictions, a new way of observing the cosmos, not through light, but through the vibrations of space-time itself. But as the detectors were refined, as more observations were made, something unexpected emerged. A background noise, a persistent signal coming from all directions at once. The gravitational wave background, a hum of space-time vibrations filling the universe, and we don't yet know what's creating it. Perhaps it's the combined effect of countless distant collisions, black holes and neutron stars merging throughout cosmic history, their waves overlapping, blending into a single persistent tone. Perhaps it's something from the very early universe, vibrations set in motion during the first moments after the Big Bang, still echoing through space today. Or perhaps it's something else entirely, something we haven't imagined yet. The detectors are improving, more observations are being made, and slowly, carefully, scientists are beginning to separate the hum into its components, trying to identify which sources contribute to the background. But for now, it remains largely mysterious, a cosmic drone, a vibration underlying everything, the sound of space-time itself resonating. And space-time is full of mysteries. One of the deepest questions in physics is what space-time actually is. We talk about it as though it's a fabric, something that can bend and ripple and tear. But this is metaphor. Space-time is not made of threads or particles or any substance we can point to. It is, as far as we can tell, fundamental, the stage on which everything else happens, the framework that gives meaning to location and duration. Einstein showed us that space-time is dynamic, that mass and energy curve it, that this curvature is what we experience as gravity. A planet orbits a star not because it's being pulled by some invisible force, but because it's following the straightest possible path through curved space-time. This is a beautiful picture, elegant, predictive, but it leaves questions unanswered. At the smallest scales, quantum mechanics tells us that everything fluctuates, that energy and matter exist in states of probability, spread out, uncertain, until measured. If space-time is real, if it's a physical thing, then it too should fluctuate at small scales. This leads to the idea of quantum foam, the notion that at distances far below what we can observe, space-time might be bubbling, twisting, forming, and dissolving in a chaotic dance. At these scales, the smooth fabric tears apart into something stranger, something where the very concepts of space and time lose their usual meaning. But we cannot test this. The scales involved are too small. The energies required to probe them are too high. and so the quantum nature of space-time remains theoretical, a prediction waiting for technology that may not exist for generations. Some physicists suggest that space-time might not be fundamental at all, that it might emerge from something deeper. Just as temperature emerges from the motion of molecules, space-time might emerge from the interactions of more basic entities. Information, perhaps, or quantum entanglement, or structures we don't yet have names for. If this is true, then space and time are illusions in a sense. Useful approximations that work at human scales, but break down when we look too closely. Reality, at its deepest level, might be something entirely different from what we perceive. These ideas are speculative. They exist at the boundary where mathematics meets philosophy, but they're taken seriously because the problems they address are real. The incompatibility between quantum mechanics and general relativity is not just a theoretical inconvenience. It prevents us from understanding the first moments after the Big Bang. It prevents us from understanding what happens at the center of black holes. Until we resolve this, until we find a theory that unifies quantum mechanics and gravity, some of the universe's deepest mysteries will remain closed to us. And perhaps that's fitting. Perhaps there are questions that require not just new observations or new instruments, but entirely new ways of thinking, new frameworks that we haven't developed yet because we don't know what we're missing. The history of science is full of these moments, times when progress seemed impossible, when mysteries seemed intractable, until someone made a conceptual leap that changed everything. Newton gave us laws of motion and gravity. Einstein gave us relativity and showed that space and time are connected. Quantum mechanics revealed that reality at small scales is probabilistic, uncertain, strange beyond intuition. Each of these was a revolution. Each changed not just what we knew, but how we thought about the universe. And each revealed new mysteries, deeper ones, questions that previous generations couldn't even formulate because they lacked the concepts. Perhaps we're in a similar position now. Perhaps the mysteries we face, dark matter and dark energy and quantum gravity, are waiting for a new revolution, a new way of seeing that will make the answers obvious in retrospect. Or perhaps not. Perhaps some mysteries are more stubborn. Perhaps the universe guards its deepest secrets carefully, revealing them only after centuries of patient work. Either way, the mysteries are there, and they're not going anywhere. You can let that thought settle. Let it rest alongside you. There is no urgency, no deadline. The universe has time, and so do you. Let your breath continue its gentle rhythm, in and out, slow and steady. We're going to turn our attention now to something closer, still mysterious, but within our own solar system. Objects we can visit, study, touch, if we build the right spacecraft. And yet, even here, even in our cosmic neighborhood, mysteries abound. There is a moon orbiting Saturn called Enceladus. It's small, barely 500 kilometers across, covered in pristine ice that reflects nearly all the sunlight that touches it. From a distance, it looks quiet, frozen, dead. But it's not. In 2005, the Cassini spacecraft flew past Enceladus and discovered geysers, plumes of water vapor and ice crystals erupting from cracks near the South Pole, shooting hundreds of kilometers into space. This was unexpected. Small moons are supposed to be geologically dead. They don't have enough internal heat to drive volcanic activity. They cool quickly after formation and remain frozen ever after. But Enceladus is active. Somehow, it has retained enough heat to maintain a liquid ocean beneath its icy shell, an ocean that vents into space through the cracks, the tiger stripes, as they're called, that scar the southern hemisphere. Where does the heat come from? Tidal forces. As Enceladus orbits Saturn, the planet's gravity pulls on it unevenly, flexing the moon, kneading it like dough. This friction generates heat, enough heat to keep water liquid, enough heat to drive the geysers. But this raises questions. How thick is the ice shell? How deep is the ocean? Is it a global ocean or localized to the South Pole? And most intriguingly, could there be life in that ocean? The plumes contain organic molecules, carbon-based compounds, the building blocks that, on Earth, are associated with life. They contain salts and silica particles, suggesting the water is in contact with a rocky sea floor, possibly with hydrothermal vents like those in Earth's deep oceans. On Earth, hydrothermal vents support rich ecosystems. Life thrives there, independent of sunlight, feeding on chemical energy from the planet's interior. Could the same be happening on Enceladus? Could microbes, or something like them, exist in that dark ocean beneath the ice? We don't know. The evidence is tantalizing, but not conclusive. The organic molecules could form through non-biological processes. The conditions might not be quite right for life as we understand it, but the possibility is there. Real enough that scientists are designing missions to return to Enceladus, to fly through the plumes, to collect samples, to analyze them in more detail, to search for signs, definitive signs, that we are not alone. And Enceladus is not unique. Europa, a moon of Jupiter, also has an ocean beneath ice, possibly a deeper ocean, with more water than all of Earth's seas combined. Titan, Saturn's largest moon, has lakes and rivers of liquid methane on its surface, and possibly a water ocean deep below. The outer solar system is full of hidden oceans, worlds within worlds, and each one is a place where life might exist, or might have existed once, or might exist someday. This changes how we think about habitability. For most of history, we assumed life required a planet like Earth, the right distance from the sun, the right temperature, liquid water on the surface. But now we know that oceans can exist far from the sun, kept warm by tidal heating or radioactive decay in the interior. Life, if it's anywhere beyond Earth, might be more likely to exist beneath ice than on surfaces exposed to space, and this expands the possibilities immensely. Icy moons are common. Nearly every gas giant has them. In our solar system alone, there are dozens of candidates, and if other star systems follow similar patterns, then the galaxy might be full of ocean worlds, hidden, quiet, but potentially teeming with life. Of course, this is speculation. We have no proof, no confirmed detection of life anywhere beyond Earth. But the possibility has shifted from distant dream to serious scientific question, from maybe someday to we could find out in our lifetimes. And that is exciting and humbling and somehow calming, to know that the answer to one of humanity's oldest questions, are we alone, might be waiting beneath the ice of a small moon only 1 billion kilometers away. You can rest with that image: dark oceans, hidden beneath ice, silent, patient, holding secrets that might one day be revealed. There is no rush. The moons will still be there. The oceans will still be there. And the question of what might live within them will remain, waiting for the spacecraft we'll build, the missions we'll send, the discoveries we'll make, slowly, carefully, in time. Let your body sink a little deeper now. Let whatever surface you're resting on support you fully. There is nothing you need to hold up, nothing you need to maintain. We're going to drift now to another mystery, one that exists not on a moon or a planet, but in the space between worlds, in the outer reaches of the solar system, where sunlight is faint and the cold is absolute. There are objects out there, small bodies, remnants from the formation of the solar system, and their behavior is teaching us that we still have much to learn about how planets form, about the forces that shape the early solar system, about the processes that turn clouds of gas and dust into the ordered systems of planets and moons we observe today. The Kuiper Belt, a vast ring of icy bodies beyond Neptune's orbit, stretching from about 30 times Earth's distance from the Sun to 50 times that distance, perhaps even farther. We're still mapping it, still discovering objects we didn't know were there. Pluto is the most famous resident of the Kuiper Belt. Once called the 9th planet, now classified as a dwarf planet, one among many. But Pluto is not typical. It's unusually large for a Kuiper Belt object, and its orbit is strange, tilted and elongated, crossing Neptune's path. Why? How did Pluto end up in such an odd orbit? This is part of a larger mystery about the early solar system. Computer simulations suggest that the giant planets, Jupiter, Saturn, Uranus, and Neptune, did not form where they are now. They formed closer together, nearer to the Sun, and then, through gravitational interactions with each other, and with the disk of debris left over from planet formation, they migrated outward. This migration was chaotic. Orbits shifted. Some objects were flung inward. Others were scattered outward. The Kuiper Belt itself might be a remnant of this chaos, populated by objects that were originally closer to the Sun and were pushed out as the planets moved. This would explain many things: the strange orbits, the gaps and clusters, the way some objects seem to have been captured from elsewhere. But the details remain uncertain. The simulations work roughly, but they require specific conditions, specific initial configurations, and we don't know if those conditions actually existed. We're learning more as we discover more objects. Each new Kuiper Belt body adds a data point. Each orbit refines our models. Slowly, the picture becomes clearer, and then there are objects even farther out, beyond the Kuiper Belt, in regions so distant that they take thousands of years to complete a single orbit around the Sun. Sedna, discovered in 2003. Its closest approach to the Sun is still 76 times Earth's distance. Its farthest point is nearly 1,000 times Earth's distance. An orbit so elongated, so extreme that it's hard to explain. What could have placed Sedna in such an orbit? Not the giant planets. Their gravity doesn't reach that far. Perhaps a passing star, billions of years ago, pulled on Sedna and flung it outward. Perhaps Sedna formed elsewhere and was captured by the Sun's gravity during a close encounter. Or perhaps there's something else out there. something we haven't found yet. Some astronomers believe there might be another planet in the outer solar system, a ninth planet, not Pluto, but something larger, farther away, massive enough to influence the orbits of distant objects like Sedna. This hypothetical Planet 9 would be several times the mass of Earth, orbiting hundreds of times farther from the Sun than we are. Out there, it would be cold, dark, difficult to see even with powerful telescopes. The evidence for Planet 9 is indirect, a pattern in the orbits of several distant objects, a clustering that seems too regular to be coincidence, as though something massive is shepherding these objects, keeping their orbits aligned. But this is not proof. The pattern could be coincidence, or it could be an artifact of the way we search for objects, a bias in where we look that creates apparent structure where none exists. Searches are ongoing. Telescopes scan the sky, surveys deepen, and if Planet 9 is there, if it exists, we will find it eventually. The solar system is large, but not infinite. Every patch of sky can be checked, every faint point of light analyzed. But for now, the outer solar system remains a place of mystery, a region we've barely explored, where objects drift in darkness, where the sun is just another star, where cold and silence reign. And perhaps that's appropriate. The edges of our solar system mirror the edges of our knowledge. Both fade into uncertainty. Both hint at things beyond. Both remind us that even in our own cosmic backyard, there are secrets waiting to be uncovered. You can let your mind drift through that darkness now. Let it wander among the distant objects, the slow-moving bodies, the frozen worlds at the edge of the sun's influence. There's a peace in that distance, a stillness. Nothing happens quickly out there. Orbits take millennia. Changes unfold over geological time. There is no urgency, no rush, just the slow, patient turning of the cosmos. There is a region of space between Mars and Jupiter where something failed to become. The asteroid belt. Millions of rocky fragments, ranging from grains of dust to bodies hundreds of kilometers across, orbiting the sun in a broad band. Collectively, they contain less mass than our moon, scattered across a volume so vast that spacecraft can pass through without coming close to any single object. This is what remains of a planet that never formed. In the early solar system, as dust and gas collapsed into the sun, material also gathered into rings around it. Within these rings, particles collided, stuck together, grew. This is how planets form. Gradual accumulation. Dust to pebbles, pebbles to boulders, boulders to planetesimals, planetesimals to planets. But in the region between Mars and Jupiter, this process was interrupted. Jupiter's gravity was too strong. It stirred the material, accelerated collisions, prevented accumulation. Instead of merging peacefully, objects smashed into each other violently, breaking apart as often as they joined. And so, no planet formed, only fragments, a scattered field of debris, the asteroid belt. Or so the story goes. But even this simple narrative hides mysteries. Why are there so few asteroids? If the asteroid belt is the remnant of planet formation, it seems remarkably depleted. Most of the original material must have been scattered elsewhere, flung into the inner solar system, ejected entirely. or perhaps absorbed by Jupiter itself. But the details of this clearing process are unclear. Computer models can reproduce something like the asteroid belt, but they require careful tuning, specific assumptions about Jupiter's migration, about the density of the original disk, about the timing of events. And different models make different predictions. Some suggest the asteroid belt should be more massive. Others suggest different compositional gradients. The observations don't always match the expectations. There's also the question of why asteroids vary so much. Some are rich in metals, others are rocky. Still, others are dark, carbon-rich, almost like frozen tar. This diversity tells us they formed in different regions, under different conditions. But how did they end up mixed together? The asteroid belt is not neatly organized. Metal-rich asteroids and carbon-rich asteroids orbit side by side, as though something shuffled them, mixed them, scattered them into their current arrangement. Jupiter's migration could explain this. As Jupiter moved inward and then outward again, its gravity would have stirred the asteroid belt thoroughly, mixing objects that formed at different distances from the Sun. But again, this requires specific conditions, a specific history. And we don't have a recording of the early solar system. We can only infer, only reconstruct, only build models and test them against what we see today. Some asteroids are strange in other ways. Psyche, for example, appears to be almost entirely metal, iron and nickel, as though it's the exposed core of a larger body that was shattered by collisions, leaving only the dense metal center behind. NASA is sending a spacecraft to Psyche. It will arrive in 2029, orbit the asteroid, study its surface, measure its composition. If Psyche really is a planetary core, it offers a unique opportunity. We can never drill to the core of Earth or any other planet. The depths are too great, the conditions too extreme. But Psyche might give us a direct look at what planetary cores are like, what they're made of, how they form, how they contribute to the magnetic fields that some planets generate. Or Psyche might turn out to be something else entirely. Perhaps it's not a core at all, but a strange type of asteroid that formed metal-rich from the beginning. We won't know until we arrive, until we see it up close. And this is a recurring theme in solar system exploration. Every time we visit a new world, we find surprises, things that don't quite fit the models, features that suggest histories more complex than we imagined. Ceres, the largest object in the asteroid belt, was thought to be a simple rocky body. But when the Dawn spacecraft arrived, it found bright spots on the surface, deposits of salt, evidence of water beneath the crust, perhaps even cryovolcanoes, ice volcanoes, erupting brines instead of lava. Ceres, it turns out, is more like a moon than an asteroid, a differentiated body with a core, mantle, and crust, perhaps once with an ocean, perhaps still with pockets of liquid water deep below. This blurs the categories we use: asteroid, moon, planet, dwarf planet. These labels are human constructs, attempts to organize what we see. But nature doesn't follow our labels. Reality is messier, more complex, full of objects that sit between categories that challenge our definitions. And perhaps that's a lesson worth carrying forward, that the universe is not obligated to fit our expectations, that mystery and surprise are not problems to be eliminated. but natural parts of exploration. Every answer leads to new questions. Every discovery reveals new mysteries. And this is not a failure of science. It is its strength, the willingness to revise, to update, to follow the evidence wherever it leads, even if it leads somewhere unexpected. You can let your breath deepen now. Let the tension in your jaw soften. Let your tongue rest easily in your mouth. These small releases add up. Each one allows a little more rest to settle in. We're going to move inward now, closer to the sun, to the planets that orbit in the warmth and light, the terrestrial planets, rocky worlds, Earth, Venus, Mars, Mercury. And even here, in the most studied region of the solar system, mysteries remain. Mercury is strange. It's the smallest planet, barely larger than some moons. Its surface is scarred with craters, ancient impacts from the early days of the solar system when debris was still abundant. But Mercury also has something no one expected: a magnetic field. Most magnetic fields in the solar system are generated by dynamos, liquid metal in planetary cores, stirred by the planet's rotation, creating electric currents that produce magnetic fields. Earth has a strong dynamo, so does Jupiter. But Mercury is tiny, and small planets cool quickly. By all expectations, Mercury's core should have solidified long ago. No liquid, no dynamo, no magnetic field. And yet, the field is there. Weak, only about 1% of the strength of Earth's, but real, measurable. How? Perhaps Mercury's core is not fully solid. Perhaps a thin outer layer remains liquid, sustained by sulfur or other impurities that lower the melting point. Perhaps this thin layer is enough to generate the weak field we observe. Or perhaps something else is happening. Perhaps Mercury's magnetic field is a remnant, a fossil from when the core was entirely liquid, somehow frozen into the planet's structure and persisting to this day. We don't know. The data is sparse. Mercury has only been visited by 2 spacecraft, Mariner 10 in the 1970s and Messenger in the 2000s. Both provided valuable information, but many questions remain. And Mercury holds other mysteries. Its surface is darker than expected, as though covered in something that absorbs light, perhaps carbon, perhaps some other material, delivered by ancient comets or formed through processes we don't fully understand. There are also strange features called hollows, small, shallow depressions scattered across the surface with bright, reflective floors. They look fresh, recent, as though they're still forming today. But what creates them? Perhaps volatile materials buried beneath the surface are evaporating in the heat of the sun. Perhaps the solar wind, streams of particles from the sun, is eroding the surface in some way. Theories exist, but the process remains unclear. Mercury is full of small mysteries like this, features that hint at active processes, at a world more dynamic than its cratered, dead appearance suggests. Venus is perhaps the most mysterious of all. From space, Venus looks serene, covered in thick clouds, pale yellow, featureless, beautiful in its simplicity. But beneath those clouds is hell. The surface temperature is hot enough to melt lead. The atmospheric pressure is 90 times that of Earth, equivalent to being a kilometer underwater. The clouds are made of sulfuric acid, rain that never reaches the ground, evaporating in the heat long before it lands. Venus should not be this way. It's nearly the same size as Earth, nearly the same mass. It orbits only slightly closer to the Sun. By all rights, it should be Earth's twin, a temperate world, perhaps with oceans, perhaps even with life. But something went catastrophically wrong. Venus experienced a runaway greenhouse effect. Water vapor trapped heat. The heat evaporated more water. The cycle fed on itself until the oceans boiled away and the surface became an oven. Or so the theory goes, but the details are unclear. When did this happen? How quickly? Was Venus ever cool enough to have liquid water? If so, for how long? There are hints that Venus might have had oceans once. The ratio of hydrogen isotopes in the atmosphere suggests water was present and then lost to space. Computer models show that a slow-rotating planet like Venus could, in principle, have been habitable for billions of years, even this close to the Sun. But we have no direct evidence. Venus's surface is young, geologically speaking, about 500 million years old. Volcanic activity has resurfaced the planet, erasing whatever features existed before. And this volcanic activity is itself mysterious. Venus has no plate tectonics, no continental drift. Its crust is a single solid shell, and yet it has more volcanoes than any other planet in the solar system. Thousands of them, some enormous. Ma'at Mons rises 8 kilometers above the surrounding plain, comparable to Earth's largest volcanoes. Are any of these volcanoes active today? We don't know. Some observations suggest possible recent activity. Changes in sulfur dioxide levels in the atmosphere, bright spots on the surface, possibly fresh lava. But the evidence is ambiguous. Venus's thick clouds make observation difficult. Radar can penetrate them, mapping the surface, but only at low resolution. Visible light doesn't make it through at all. To study Venus properly, we need to send spacecraft, landers, orbiters, probes that can survive the extreme conditions long enough to gather data. Several missions have tried. The Soviet Venera probes landed successfully in the 1970s and 1980s, sending back images and measurements before succumbing to the heat. But they lasted less than 2 hours. Most failed much sooner. New missions are planned. Better technology, better materials. Perhaps we'll finally understand what happened to Venus. Why Earth's twin became a hell world, whether it was always this way, or whether something changed. And this question matters, not just for Venus, but for understanding planets in general, for predicting which exoplanets around other stars might be habitable, for knowing how close to a star is too close, how thick an atmosphere can be before a greenhouse effect runs away. Venus is a cautionary tale, a reminder that planets are fragile, that small changes can have enormous consequences, that the line between habitable and uninhabitable might be thinner than we'd like to think. But it's also a reminder of how much we still don't know, how many mysteries remain, even in our own solar system. Worlds we've studied for centuries, and yet they still surprise us, still challenge our understanding, still hold secrets. You can let your shoulders drop now. Let your arms rest heavily. Let gravity pull pull gently on your body, reminding you that you're supported, that you don't need to hold yourself up, that you can simply be. Mars was not always the cold, dry desert it is today. Billions of years ago, water flowed on Mars. Rivers carved valleys. Lakes filled impact craters. Perhaps even oceans covered parts of the northern lowlands, shallow seas under skies that might have been blue. The evidence is everywhere. Ancient riverbeds, delta formations, layered sediments, minerals that only form in the presence of water. Mars was once a wetter world, warmer, perhaps more like Earth. But something changed. The water disappeared. The climate shifted. Mars became the frozen desert we see today, a world where carbon dioxide snow falls at the poles, and the thin atmosphere cannot sustain liquid water on the surface. What happened? The leading theory points to the loss of Mars's magnetic field. Early in its history, Mars had a global magnetic field, generated by a dynamo in its molten core. This field protected the atmosphere from the solar wind, the stream of charged particles flowing from the sun. But Mars is smaller than Earth. It cooled faster, and about 4 billion years ago, the dynamo shut down. The magnetic field vanished. Without that protection, the solar wind began stripping away the atmosphere, slowly, particle by particle, over millions of years. As the atmosphere thinned, the surface pressure dropped. Water could no longer remain liquid. It either froze or evaporated. Much of it was lost to space, carried away by the same solar wind that stripped the atmosphere. What remains is locked in ice, at the poles, underground, frozen into the soil. Mars is not dry exactly. It still has water, but it's trapped, inaccessible, waiting, and this raises questions. If Mars once had liquid water, if it once had a thicker atmosphere, could it have had life? We know that on Earth, life appeared early. As soon as the surface cooled enough to allow liquid water, life emerged. Microbial life, simple but persistent, filling every available niche. If life is a natural consequence of liquid water and organic chemistry, then Mars might have had life too, during those early, wetter years, before the atmosphere was lost, before the rivers dried. And if life began on Mars, did it survive? Could it still exist today, deep underground, in pockets of liquid water, sheltered from the harsh surface? This is one of the driving questions behind Mars exploration. We've sent rovers, landers, orbiters, all searching for signs of past or present life. We've drilled into rocks, analyzed soil, searched for organic molecules, and we found hints. Organic molecules are present. Methane appears in the atmosphere, sometimes in bursts, suggesting active sources. Seasonal changes that could be biological, though they could also be chemical or geological. But no definitive proof, no fossils, no clear biosignatures, only tantalizing possibilities. Suggestions, maybes. Perhaps life never began on Mars. Perhaps the conditions weren't quite right. Perhaps the window of habitability was too brief. Or perhaps life did begin, but left no traces we can recognize. No remains, no markers, only the silence of deep time. Or perhaps we haven't looked in the right places yet. Mars is large. We've explored only a tiny fraction of its surface. The most interesting regions, from a habitability standpoint, are often the most difficult to reach. Deep canyons, polar ice, subsurface aquifers. Future missions will go to these places, will drill deeper, will search more thoroughly, and perhaps one day we'll find something. A fossil, a chemical signature, a living microbe in a subsurface lake. Or perhaps we won't. Perhaps Mars kept its secrets. Perhaps life, if it ever existed there, vanished completely, leaving only the silent rocks and dust. Either way, the question will persist. The mystery will remain. Until we have an answer, Mars will continue to haunt us with possibility, with the tantalizing suggestion that we are not, and perhaps never were, alone. You can rest with that uncertainty now. Let it wash over you. There is no need to resolve it tonight, no need to find answers. The mystery is enough. The question is enough. Let your breathing continue. Slow, steady. Each breath a little deeper than the last. Each exhale releasing a little more tension. We're going to move through a few more mysteries now. Quieter ones, smaller scales, but no less profound in their way. There is a light in the sky that moves in ways we don't fully understand. Auroras, the northern and southern lights, curtains of green and red and purple, shimmering across polar skies, dancing with a motion that seems almost alive. We know what causes them in broad strokes. Charged particles from the sun, carried by the solar wind, interact with Earth's magnetic field. Some of these particles are funneled toward the poles, where they collide with atoms in the upper atmosphere. These collisions transfer energy, exciting the atoms, causing them to emit light. Oxygen produces green and red. Nitrogen produces blue and purple. The colors depend on the altitude, the energy of the particles, the type of atom excited. This explanation works. It accounts for the basic phenomenon. But when we look closely at auroras, when we study them in detail, we find structures and behaviors that don't fit neatly into simple models. There are auroral arcs, stable bands of light that can stretch for thousands of kilometers. There are flickering auroras, pulsating like a heartbeat. There are discrete auroral forms, small, bright patches that appear and vanish in seconds. There are curls and folds, waves and ripples, patterns that suggest complex dynamics in the magnetosphere, in the region of space where Earth's magnetic field dominates. And there's something called STEVE, strong thermal emission velocity enhancement, a narrow ribbon of purple light stretching east to west across the sky, accompanied sometimes by green picket fence structures, vertical columns of light marching beside it. STEVE was known to aurora watchers for years, photographed and documented, but dismissed by scientists as a typical aurora, until recently, when careful analysis showed it's not a typical aurora at all. It occurs at lower latitudes, at different altitudes, with different physics. STEVE is caused by a river of hot, fast-moving plasma in the ionosphere, a jet stream of charged particles flowing at several kilometers per second, heated to thousands of degrees. Why this jet forms, why it appears when it does, and what relationship it has to the more familiar auroras, we're still working out. Auroras remind us that even common phenomena, things people have watched for millennia, can harbor mysteries. That what seems understood at first glance may reveal complexity upon closer inspection. And Earth's magnetosphere itself is full of mysteries. The magnetosphere is the region around Earth shaped by our planet's magnetic field. It's not a simple bubble. It's compressed on the side facing the sun, where the solar wind pushes against it, and stretched into a long tail on the night side, extending millions of kilometers downstream. Within this region, particles spiral along field lines, trapped, forming the Van Allen radiation belts. These belts protect us by capturing high-energy particles that would otherwise reach the surface. But they also pose hazards to satellites and astronauts, concentrations of radiation intense enough to damage electronics and harm living tissue. The belts were discovered in the 1950s by some of the first satellites launched into space, and they've been studied extensively since. But they still surprise us. In 2012, NASA spacecraft discovered a third radiation belt, temporary, appearing and disappearing over the course of weeks. No one predicted it. The models didn't show it. And yet there it was, a distinct band of particles, separated from the two known belts. It formed, persisted for a few weeks, then merged with the outer belt and vanished. Why? The details involve complex interactions between the solar wind, Earth's magnetic field, and electromagnetic waves rippling through the magnetosphere. But the fact that such a structure could appear, unannounced, in a region of space we thought we understood, is humbling. It suggests that the magnetosphere is more dynamic, more variable than we realized, and there are other phenomena. Magnetic reconnection, where field lines break and rejoin, releasing enormous amounts of energy in sudden bursts. This happens constantly in the magnetosphere, but we don't fully understand how it starts, or why it happens when and where it does. There are chorus waves, electromagnetic whistles that sweep upward in frequency, accelerating particles to high energies. There are substorms, sudden releases of energy that light up auroras and disturb the magnetic field. All of these are pieces of a larger puzzle, the puzzle of how magnetic fields, charged particles, and plasma interact. How energy flows through these systems, how they respond to external forcing, like changes in the solar wind. Understanding this matters, not just for Earth, but for predicting space weather, solar storms that can disrupt satellites, communication systems, power grids, events that, in our increasingly technological world, carry real risks. And beyond practical concerns, understanding the magnetosphere helps us understand other planets, other magnetic fields. Jupiter's magnetosphere is enormous, dwarfing Earth's. Saturn has a magnetosphere shaped by its moon Enceladus, which pumps water vapor into space, seeding the magnetic field with particles. Every magnetic field tells a story about the planet's interior, about its history, about the interactions between the planet and its environment. And each one is slightly different. Each one presents unique challenges, unique mysteries. You can let your eyes remain closed now. Let the darkness be comfortable. There's no need to see anything. Just rest in the blackness behind your eyelids. Soft, encompassing, gentle. There is a boundary where the sun's influence fades and interstellar space begins, but the exact location of this boundary is uncertain, and what lies beyond is only partly known. The heliosphere, the bubble of space carved out by the solar wind, the stream of particles flowing constantly from the sun, expanding outward at hundreds of kilometers per second, pushing back the thin gas of interstellar space. Within the heliosphere, we're protected. The solar wind acts as a shield, deflecting most galactic cosmic rays, high-energy particles from distant supernovae and other sources. Without this protection, Earth would be bathed in higher levels of radiation. But eventually, the solar wind slows, runs out of energy, meets resistance from the interstellar medium, and somewhere out there, far beyond the planets, the solar wind stops. The heliosphere ends. This boundary is called the heliopause, and 2 spacecraft have crossed it. Voyager 1 in 2012, Voyager 2 in 2018. Both spacecraft detected sudden changes. The density of particles increased. The magnetic field shifted. The direction of particles changed, no longer flowing from the Sun, but from interstellar space. They had left the solar system, in a sense, entered the galaxy proper, a region where the Sun is just one star among billions, with no special influence. But the crossing was not sharp, not a single clear line. Instead, there were layers, regions, a boundary region where solar and interstellar influences mixed, and the 2 spacecraft, crossing at different locations, found different conditions, suggesting that the heliopause is not uniform, not a simple sphere, but complex, shaped by the interstellar magnetic field, by the motion of the solar system through the galaxy, by turbulence and variations in the solar wind. We're still learning what the heliopause looks like, how thick it is, how it changes over time. The Voyagers are sending back data, but they're traveling in only 2 directions. They can't map the full structure. They give us only narrow slices, cross-sections through a vast 3-dimensional boundary. And beyond the heliopause lies interstellar space, the void between stars, not truly empty, but filled with thin gas, dust, magnetic fields, cosmic rays. Interstellar space is quieter than the heliosphere. The solar wind no longer dominates, but it's not entirely calm. There are clouds of denser gas, bubbles blown by ancient supernova, shock waves from massive stars and stellar explosions. Our solar system is currently passing through one of these clouds, the local interstellar cloud, a region of slightly higher density, part of a larger structure called the local bubble, a cavity carved out by supernovae millions of years ago. We're swimming through these structures, moving at about 20 kilometers per second relative to the surrounding gas, and this motion shapes the heliosphere, compressing it in the direction we're traveling, stretching it out behind. In a few thousand years, we'll pass out of the local interstellar cloud into a different region, and the heliosphere will change shape in response. The boundary will shift. The level of protection will adjust. These are slow changes, playing out over timescales far beyond human lifetimes. But they remind us that even the space around our Sun is not static, not unchanging. It's a dynamic interface between the Sun and the galaxy, constantly adjusting to the conditions around it. And the galaxy itself is full of these boundaries. Every star has a heliosphere. Every star carves out a bubble in the interstellar medium, and these bubbles overlap, interact, merge, creating a frothy structure on scales too large to fully visualize. We're part of that structure, part of the vast, churning ecosystem of the galaxy, connected to everything around us in ways we're only beginning to understand. You can let that sense of connection settle now. Let it be gentle, not overwhelming, but quietly present. A reminder that you are part of something larger, something ancient, something ongoing. Let your breath find a rhythm that feels natural. Let your body adjust. shifting slightly if needed, finding comfort. There is a phenomenon that occurs on Earth, rare but unmistakable, that we still cannot explain fully. Ball lightning, glowing spheres that appear during thunderstorms, floating through the air, drifting into buildings through open windows, lasting for seconds, sometimes minutes, before vanishing or exploding with a soft pop. Reports of ball lightning go back centuries. Sailors described glowing balls rolling across ship decks during storms. Pilots have seen them appear near aircraft. Scientists have documented cases where ball lightning entered laboratories, drifted past astonished researchers, and disappeared. For a long time, ball lightning was dismissed, considered folklore, optical illusions, exaggerations of regular lightning. But the reports are too consistent, too detailed, too numerous to dismiss entirely. And in recent years, a few instances have been captured on video, recorded by chance during storms. The evidence is clear. Ball lightning is real. But what is it? This remains uncertain. One theory suggests it's a ball of plasma, ionized gas held together by magnetic fields, perhaps created when regular lightning strikes the ground, vaporizing silicon and other materials, which then react in the air to form a glowing sphere. Another idea involves microwave radiation, trapped in a resonant cavity formed by atmospheric layers, creating a sustained electric field that ionizes air in a localized region. Still others propose exotic chemistry, oxidation reactions, nanoparticles burning slowly, quantum effects we don't yet understand. Laboratory experiments have created things that look somewhat like ball lightning, briefly glowing spheres, but none reproduce all the reported characteristics. None last as long. None behave quite the same way. And so ball lightning remains a mystery. Rare enough that it's difficult to study. Common enough that it can't be ignored. A reminder that Earth's atmosphere, for all we've learned about it, still holds surprises. And Earth is full of such surprises. Phenomena on the edge of understanding. Things glimpsed briefly and then gone. Sprites. Red flashes high above thunderstorms, reaching toward space. They were reported by pilots for decades before being photographed. Now we know they're electrical discharges in the mesosphere, triggered by lightning below. But the details of their formation are still being worked out. Elves, expanding rings of light, even higher than sprites, caused by electromagnetic pulses from lightning interacting with the ionosphere. Blue jets, narrow cones of blue light shooting upward from storm clouds. All of these were discovered only in recent decades. Some suspected for longer, but confirmed only when cameras sensitive enough and pointed in the right directions captured them. And there may be more. Other transient phenomena. Other brief electrical discharges. Other interactions between the atmosphere and space that we haven't yet documented. The atmosphere is thicker than we sometimes remember. It extends from the surface where we live to hundreds of kilometers up, gradually thinning until it merges with the vacuum of space. And throughout this thickness, processes are occurring. Chemistry, physics, electricity, wind, pressure. Most of it we understand reasonably well, but not all. There are details still being worked out, processes still being discovered, interactions that depend on specific conditions, that only occur rarely, that surprise us when they appear. And perhaps this is fitting. Earth is our home. We've studied it intensively, mapped every continent, probed every ocean, monitored the atmosphere from satellites and balloons and ground stations, and yet it still surprises us, still reveals new phenomena, still holds corners of mystery in its air and water and rock. This should be comforting in a way. If Earth, familiar and close, can still surprise us, then the universe, vast and distant, will never run out of mysteries to offer. There will always be more to discover, always new questions to ask, always phenomena we haven't encountered yet, waiting patiently in the places we haven't looked. Let that thought rest with you. Let it be a gentle presence, not demanding anything, just there, a quiet truth. You can allow your jaw to slacken now. Let your teeth part slightly. Let your tongue rest against the roof of your mouth, soft and still. These small releases matter. Each one is a doorway to deeper rest. Each one allows your body to settle a little further into stillness. We're going to turn now to mysteries of time, of perception, of the way the universe seems to flow in one direction, always forward, never back, and the puzzles this creates, the questions it raises. Why does time have a direction? Why can we remember the past but not the future? Why do broken things never spontaneously repair themselves? These questions sound simple, almost naive, and yet they touch on some of the deepest problems in physics. At the level of individual particles, time is reversible. The equations that describe how particles move work equally well, whether time flows forward or backward. A film of particles colliding, if played in reverse, would show equally valid physics. And yet, in the everyday world, time clearly has a direction, an arrow, pointing from past to future, never the other way. This arrow seems to be connected to entropy, to disorder. The second law of thermodynamics states that entropy, disorder, always increases, never decreases. A broken glass will not reassemble. Heat will not spontaneously flow from cold to hot. Ink dropped in water will spread out, never gather back into a drop. But why should entropy increase? The fundamental laws don't require it. They allow entropy to decrease. It's just extraordinarily unlikely. And this is where probability enters, where statistics becomes part of the story. There are many more ways for a system to be disordered than ordered. Many more configurations of molecules in a room where they're spread evenly than configurations where they're all in one corner. So when particles move randomly, they naturally drift toward more probable states, toward higher entropy, not because of any law forbidding the reverse, but simply because those states are vastly more likely. But this raises a question. If entropy always increases, if disorder always grows, then the universe must have started in a very low entropy state, very ordered, very unlikely. Why? What set the universe up that way? What made the beginning so special, so improbable? This is one of the deepest mysteries in cosmology. The initial conditions problem. The question of why the Big Bang produced a universe poised to evolve in the direction we observe. Some physicists suggest that the universe simply started that way, that the initial state is a brute fact, not explainable through deeper principles. Others propose mechanisms. Perhaps inflation, The rapid expansion thought to have occurred in the first moments smoothed out irregularities, creating a uniform, low-entropy beginning. Or perhaps our universe is part of a larger multiverse, and we observe a low-entropy beginning because only such universes allow for observers. Anthropic reasoning. We exist in this universe because it's the kind of universe where existence is possible. But none of these answers feel complete. None fully resolve the puzzle. Why should the laws be such that low-entropy states give rise to observers? Why should inflation happen at all? The questions recede, but don't disappear. Each answer opens new depths, new mysteries beneath the mysteries. And so the arrow of time remains, fundamentally unexplained. We can describe it. We can trace its consequences. We can make accurate predictions based on the assumption that entropy increases. But why it points the way it does, why there is an arrow at all, why the universe began in a special state that allows time to have a direction, these questions linger, unresolved, open, waiting for insights we haven't had yet. You don't need to solve them tonight. You don't need to carry them forward into sleep. You can let them fade, let them recede into the background. Just thoughts, just questions, just words spoken into the dark. Your body knows how to rest. It doesn't need understanding, doesn't need answers. It only needs permission. The gentle allowance that it's okay to let go, to stop holding on, to simply be. And you can give that permission now, quietly, without fanfare. Just a soft release, a gentle yielding. Time will continue, forward, always forward, carrying us all. But for now, in this moment, time can slow, can soften, can become less urgent, less demanding. Just breath, just rest, just the slow, patient rhythm of being alive. There is a question that philosophers and scientists have asked for centuries, and we are no closer to answering it now than we were at the beginning. What is consciousness? You are aware, reading these words, thinking thoughts, feeling the surface beneath you, hearing sounds perhaps in the distance, experiencing the quiet flow of your own mind. This experience, this awareness, this sense of being someone, is consciousness. And it is the most immediate, undeniable fact of your existence. You know you are conscious because you are experiencing consciousness right now, and yet we cannot explain it. Neuroscience has made enormous progress. We can map the brain in exquisite detail. We can identify which regions activate during different tasks. We can trace neural pathways, measure electrical signals, watch as information flows through networks of neurons. We know that damage to certain brain regions affects consciousness in specific ways. Damage to the visual cortex eliminates visual experience. Damage to language areas impairs speech and comprehension. The contents of consciousness clearly depend on the brain. But none of this explains why there is experience at all, why the physical processes in the brain should feel like something, why there should be an inner life, a subjective perspective, a sense of what it's like to be you. This is called the hard problem of consciousness. Not the question of how the brain processes information, which is difficult but approachable, but the question of why processing feels like anything, why there is experience accompanying the mechanisms. Some philosophers argue that consciousness might be fundamental, that it's not produced by the brain, but is a basic feature of reality, like mass or charge. In this view, the brain doesn't create consciousness, but rather channels it, shapes it, gives it structure. Others suggest consciousness emerges from complexity, that when information is integrated in certain ways, when systems become sufficiently interconnected and recursive, awareness arises naturally. Consciousness as an emergent property, appearing when the right conditions are met. Still others think we're asking the wrong question, that consciousness is not a single thing, but a collection of processes, and what we call awareness is just the brain's way of modeling itself, creating a narrative, a sense of unity, where none truly exists. But none of these ideas are proven. None can be tested definitively, because consciousness is inherently subjective. You cannot measure another person's experience directly. You can only infer it from behavior, from reports, from neural correlates, and this creates a fundamental limit, an unbridgeable gap, between the objective, third-person perspective of science and the subjective, first-person perspective of consciousness. I can study your brain. I can see which neurons fire when you see the color red. But I cannot access your experience of redness. I cannot know what it's like for you, whether your red is the same as my red, whether we even experience color in the same way. This is the problem of qualia, the problem of subjective qualities, the redness of red, the painfulness of pain, the particular feel of each sensation, thought, and emotion. Qualia seem private, ineffable, impossible to fully communicate. You can describe a color, but the description never captures the experience itself. You can explain what pain is, but no explanation conveys what pain feels like to someone who has never felt it. And yet, qualia are all we have. All experience is composed of them. The entire richness of conscious life is made of these subjective qualities. So consciousness remains a mystery, central to our existence, undeniably real, and yet unexplained, possibly unexplainable through the methods of current science. Perhaps future discoveries will change this. Perhaps we'll find a theory of consciousness that makes it understandable, that bridges the gap between objective brain function and subjective experience. Or perhaps consciousness will remain forever mysterious, a puzzle at the heart of what it means to be alive, to be aware, to be anything at all. You can rest with that mystery now. You don't need to solve it. You don't even need to fully understand it. Consciousness simply is, and you are it, experiencing itself, aware of awareness. Let that be enough. Let it be simple, just being, just existing, just the gentle hum of awareness, requiring nothing, explaining nothing, simply present. Let your attention soften now. Let it become less focused, less directed. Allow your thoughts to drift without following them, like clouds passing across the sky. Present for a moment, then gone. We're going to move through a few more mysteries now, shorter ones, gentler ones, questions that arise from the ordinary world around us, things we encounter every day but rarely stop to wonder about. Why do we dream? Every night, most people dream. Sometimes vivid narrative dreams, sometimes fragmented images, sometimes abstract sensations, impossible to describe. And we've learned a lot about dreaming. We know it occurs primarily during REM sleep, rapid eye movement sleep, when brain activity increases and the body becomes temporarily paralyzed, preventing us from acting out our dreams. We know that most mammals dream. Dogs twitch and whimper in their sleep. Cats' paws move as if running. Even birds show signs of REM sleep. We know that dreaming seems important. People deprived of REM sleep become irritable, have difficulty concentrating, show impaired memory. The brain needs to dream for reasons that aren't entirely clear. But what are dreams for? Why does the brain create these strange, often illogical narratives? One theory is that dreams help consolidate memories, that during sleep, the brain replays experiences, strengthening important connections, pruning unnecessary ones. Dreams might be the subjective side of this process, the conscious experience of memories being processed and filed away. Another idea is that dreams allow emotional regulation, that they provide a safe space to work through fears, anxieties, conflicts, a kind of internal therapy where difficult emotions can be experienced and resolved without real-world consequences. Still others suggest dreams are a form of simulation, that the brain practices responses to threats, rehearses social interactions, explores possibilities. Evolution favoring individuals who could mentally prepare for future challenges. Or perhaps dreams are noise, random firing of neurons during sleep, with the brain's narrative centers trying to make sense of the chaos, weaving disparate signals into stories. Each theory has support. Each explains some aspects of dreaming, but none captures everything. The full function of dreams, if they have a function, remains uncertain, and some dreams are stranger than others. Lucid dreams, where the dreamer becomes aware they're dreaming and can sometimes control the dream's content. These occur spontaneously for some people, can be learned with practice by others. What allows lucidity? Why does the brain sometimes recognize it's dreaming while usually accepting the dream as reality? The mechanisms are being studied, but much remains unknown. There are also recurring dreams, the same scenario appearing night after night, the same anxieties playing out in similar ways. What causes these repetitions? Why does the brain return to the same themes? And what about nightmares? Why do we sometimes dream of terrible things? Fear, danger, loss. These dreams can feel more vivid, more emotionally intense than pleasant dreams. Why? Perhaps they reflect unresolved anxieties. Perhaps they're the brain's way of preparing for threats. Or perhaps they're simply the inevitable result of a brain that experiences fear, that remembers dangers, that processes these emotions during sleep. Whatever their purpose, dreams remain mysterious. A nightly journey into strangeness. A reminder that even our own minds are not fully known to us. You might dream tonight, or you might not remember if you do. Either way, your brain will cycle through its stages of sleep, will process the day, will prepare for tomorrow, doing whatever it does in the hours of darkness. And you don't need to understand it, don't need to direct it. Your brain knows what to do, has done it every night of your life, will continue long after your conscious mind has released its grip and drifted into whatever dreams may come. Let your eyelids grow heavier. If they're not already closed, let them close now, gently, naturally, no effort required. There is another mystery about sleep itself. Why do we need it at all? Sleep seems like a vulnerability. Animals that sleep cannot watch for predators, cannot search for food, cannot mate or defend territory. Sleep should be a disadvantage, something evolution would eliminate. And yet, every animal sleeps. Some only briefly, a few hours a day. Others extensively, like cats sleeping 16 hours or more. But all animals show some form of rest, some period of reduced activity and awareness. This universality suggests sleep is essential. But essential for what? We know that sleep deprivation is harmful. Go without sleep long enough, and cognitive function deteriorates. Reaction times slow. Memory fails. Hallucinations can occur. Eventually, prolonged sleep deprivation is fatal. But what is sleep doing? What processes require us to lose consciousness, to become vulnerable, to spend roughly a third of our lives unconscious? One answer involves waste clearance. During waking hours, the brain's cells produce metabolic waste. These waste products accumulate in the fluid between cells. During sleep, this fluid flow increases, flushing out the waste, clearing the brain for the next day. Without this clearing, toxic proteins accumulate. These are the same proteins that build up in Alzheimer's disease and other neurodegenerative conditions. Sleep may protect against these diseases by preventing accumulation. Another answer involves synaptic homeostasis. During the day, learning and experience strengthen connections between neurons. If this continued indefinitely, the brain would become saturated, unable to form new connections. Sleep may reset these connections, weakening less important ones, strengthening the most significant, balancing the network so that tomorrow's experiences can be incorporated efficiently. There's also energy conservation. The brain uses enormous energy when awake. Sleep reduces metabolic demand, allowing the body to redirect resources to repair, growth, immune function. And there's memory consolidation, as we mentioned with dreams. Sleep helps transfer information from short-term to long-term storage, helps integrate new learning with existing knowledge. Likely, sleep serves all these functions and more. It's not a single process, but a collection of processes, each important, each requiring the specific conditions that sleep provides. But the deeper question remains: why must these processes occur during unconsciousness? Why can't the brain clear waste, consolidate memories, and rebalance synapses while awake? Perhaps consciousness itself is too energy-intensive. Perhaps the neural activity required for awareness interferes with these maintenance processes. Perhaps sleep is the only way to quiet the brain enough for the necessary work to happen. Or perhaps consciousness evolved as something that happens during waking, and sleep represents the brain's default state, the state it returns to when not actively engaged with the world. These are speculations, educated guesses. The truth is, we don't fully know why we must lose consciousness to sleep, why rest requires the cessation of awareness. Sleep remains mysterious, essential but puzzling, a daily disappearance into unconsciousness, a small death and rebirth, repeated every night of our lives. And tonight, you'll make that journey again, into sleep, into the unknown territory of dreams or dreamless rest. Your consciousness will fade, will recede, will vanish for hours, and then, when morning comes, it will return, as it always does, as though it never left, continuous, unbroken, even though there was a gap, a period of nothing, or at least nothing you remember. This, too, is a mystery. The continuity of self across sleep. How you know, when you wake, that you're the same person who fell asleep. That the consciousness returning is your consciousness. But these are questions for philosophers. For tonight, you can simply accept the mystery. Simply allow sleep to approach. Simply recognize that your body knows what to do. You don't need to understand sleep to sleep. Don't need to comprehend consciousness to be conscious. The processes will unfold on their own, as they always have. All you need to do is allow them, give permission, release control, let the natural rhythms take over. Your breath is steady now, regular. Each inhale and exhale part of a rhythm that continues without thought, without effort. You can notice this rhythm, not to control it, just to observe, to be aware of the gentle rise and fall, the cool air entering, the warm air leaving. And in noticing, you might find that the breath becomes even slower, even gentler, not because you're forcing it, but because this is what happens when attention settles, when the body recognizes it's safe to rest. We're going to explore just a few more mysteries now, moving toward the end of our journey, toward the place where questions fade and only quiet remains. There is a mystery in the fact that anything exists at all, that there is something rather than nothing. We touched on this at the beginning, but it bears returning to, because it's perhaps the deepest question we can ask. Why should there be a universe? Why should there be matter, energy, space, time? Why should there be laws of physics, regularities, patterns? These questions can't be answered by pointing to earlier causes. Even if we explain how the universe began, how it evolved, how it became what it is today, the question remains, why should any of that process exist? Some say the question is meaningless, that existence is simply a brute fact, that there is no deeper explanation, that asking why there is something is like asking what's north of the North Pole. The question assumes something that isn't there. Others suggest that perhaps non-existence is impossible, that nothingness is unstable, that something must exist because nothing cannot. Still, others point to mathematical or logical structures, suggesting that perhaps the universe exists because it's mathematically possible, and all mathematical possibilities are realized somewhere, somehow, in some larger reality. But these remain speculations, metaphysics, philosophy, beyond the reach of science, which can only study what exists, not why anything exists at all. And perhaps that's appropriate. Perhaps this is a question that cannot be answered, that lies beyond human comprehension, beyond any possible answer we could formulate or understand. The universe is, we are, and that's the starting point for everything else. You can rest in that, in the simple fact of existence, not needing to justify it, not needing to explain it, simply being, simply here, simply now. Let the mystery of existence be gentle, not troubling, not demanding, just present, like the darkness, like the silence, like the space between thoughts. Everything that exists is participating in this mystery together. the stars, the galaxies, the atoms in your body, all of it here, all of it now, all of it part of the incomprehensible fact that there is something rather than nothing. And you are part of that. You are existence becoming aware of itself, the universe looking back at itself through your eyes, through your thoughts, through your consciousness. This is worth pausing with, not to understand, just to acknowledge, to recognize. You are the universe experiencing itself, and right now, the experience is one of rest, of letting go, of drifting toward sleep. And that too is part of the mystery, part of the strange, beautiful fact of existence, that consciousness can arise, can wonder, can ask questions, and can, when it's tired, when the day is done, simply release itself back into the darkness, back into the quiet, back into rest. There are moments in the history of science when everything changed, when a single observation shattered what was thought to be certain, when reality revealed itself to be stranger than anyone imagined. In 1054, astronomers in China and Japan recorded a new star appearing in the sky. Bright enough to be visible during the day, it remained visible for weeks before fading. They called it a guest star. We know now that it was a supernova, a massive star exploding. What remains today is the Crab Nebula, an expanding cloud of gas still glowing from the energy released nearly 1,000 years ago. But at the time, it was just a mystery, a light where no light had been before, and then gone again. The heavens were supposed to be unchanging, eternal, perfect. The appearance of a new star challenged this, suggested that even the cosmos was subject to change, to creation and destruction. It would take centuries for this understanding to fully develop, for us to recognize that stars are born, live, and die, that the universe has a history, that nothing, not even the heavens themselves, is permanent. And there have been other moments like this, other observations that forced us to revise our understanding. In 1610, Galileo turned his telescope toward Jupiter and saw moons orbiting it. Not everything in the cosmos revolved around Earth. There were other centers, other systems. This was a profound shift, a step toward recognizing that Earth is not special, not central, just one world among many. In 1929, Edwin Hubble measured the light from distant galaxies and found that they were moving away from us. The farther away they were, the faster they receded. The universe was expanding. This, too, was revolutionary. The cosmos was not static, not eternal and unchanging. It had a history, a beginning. It was growing, evolving. Each of these discoveries opened new mysteries, new questions we couldn't have asked before because we didn't have the concepts. And this pattern continues. Every answer leads to deeper questions. Every solution reveals new problems. We've discovered dark matter and dark energy, but we don't know what they are. We've detected gravitational waves, but we're still learning what they can tell us about the universe. We've found thousands of exoplanets, but we don't know if any harbor life. The frontier of knowledge keeps expanding. The horizon keeps receding. No matter how much we learn, there is always more beyond. more to discover, more to wonder about. And this is not a flaw, not a failure. This is the nature of inquiry, of curiosity, of the endless human drive to understand. We are finite beings in an infinite universe. We will never know everything, never answer every question, never solve every mystery. But we keep trying, keep looking, keep wondering, because this is what we are. This is what consciousness does. It reaches out, it seeks, it questions. And in the seeking, we find meaning, not in the answers necessarily, but in the process itself, in the journey, in the act of wondering. You don't need to reach any destination tonight. Don't need to arrive at any understanding. The questions can remain open. The mysteries can remain unsolved, because the value is not in the solution. It's in the wondering itself, in the quiet contemplation of things larger than ourselves, things that stretch our minds, that remind us we are small, that there is so much we don't know. This is humbling, and in that humility there is peace. Let your body settle even more deeply now. Notice any remaining points of tension. Your forehead, your shoulders, your hands, and gently release them, not through effort, just through awareness. Just by noticing, the muscles often soften on their own, as though they were waiting for permission, for acknowledgement. And you can give that permission now. Let go. Let the tension drain away. Let gravity pull gently on every part of you. We're moving toward the end of our journey now, toward a place of rest, where the questions fade, where the mind becomes quieter, where sleep waits patiently, ready to receive you. But before we arrive there are a few more thoughts to carry with you, a few more quiet recognitions. The universe is vast, far larger than we can truly comprehend. The distances are too great, the numbers too large, the timescales too long. And yet, you are here, part of it, made of the same atoms, subject to the same laws, connected to everything through gravity, through space-time, through the fact of existence itself. Every atom in your body was forged in a star. Carbon, oxygen, nitrogen, iron, all of them created through nuclear fusion in stellar cores, released when those stars died, scattered through space, eventually gathering into clouds, into planets, into life. You are made of stardust. This is not metaphor. It is literal truth. The material of your body came from stars that died billions of years ago, before the sun existed, before Earth formed. And one day, the atoms that currently form your body will return to the cosmos. They will disperse, join other structures, other cycles, perhaps become part of future stars, future planets, future life. Nothing is permanent. Everything flows. Everything changes. Everything is part of a vast, ongoing process of transformation. And in recognizing this, there can be comfort. You are not separate from the universe, not isolated, not alone. You are part of the flow, part of the transformation, part of the ancient, ongoing dance of matter and energy. This is your place, not above nature, not outside it, but within it, part of it, one expression among countless others of the universe's endless creativity. And tonight, as you rest, as you sleep, you can carry that recognition with you. You belong here. You are exactly where you're supposed to be. Part of the great mystery, part of the endless unfolding. There is nothing you need to prove, nothing you need to accomplish, nothing you need to understand. You can simply be, simply exist, simply rest. The universe has been unfolding for nearly 14 billion years. It will continue for trillions more. Your rest, your sleep, your brief disappearance into unconsciousness is part of that unfolding. Natural, inevitable, right. Let your thoughts become even softer now, even less defined. They don't need to be clear, don't need to make sense. They can drift, dissolve, fade like stars at dawn. There is a rhythm to existence, a pattern, day and night, waking and sleeping, activity and rest. The universe breathes, in and out, expansion and perhaps someday contraction, or perhaps expansion forever, but still a rhythm, still a pattern, and you are part of that rhythm. You wake, you sleep, you engage with the world, you withdraw from it. This alternation is natural, necessary, built into the structure of life itself. You cannot be awake always, cannot be engaged always, cannot be active always. Rest is not optional. It is required, fundamental, as important as waking. And sleep is not absence, not void, not failure to be awake. It is its own state, its own process, with its own purposes, its own value. In sleep, the body repairs itself. Cells divide, tissues heal, the immune system strengthens, growth hormones are released. All the maintenance that cannot happen during waking occurs in sleep. In sleep, the brain consolidates memories, processes emotions, balances neurotransmitters, clears metabolic waste. All the invisible work that keeps the mind functioning happens in sleep. Sleep is not wasted time. It is essential time. Time when the invisible processes of life do their work. And you are approaching that time now, approaching the threshold where waking ends and sleep begins, where consciousness fades and the deeper processes take over. You might already be crossing that threshold, already drifting, already halfway into sleep. And that's perfectly fine. That's exactly right. There is no wrong way to do this. No test, no requirement. You cannot fail at falling asleep. You can only allow it. Only let it happen. And it will happen. It always does. Eventually, when the body is ready, when the mind has quieted enough, when the conditions are right, all you need to do is continue what you're already doing, lying still, breathing gently, letting your thoughts drift without following them, allowing the darkness to be comfortable. The mysteries we've explored tonight, they'll still be there tomorrow. The universe will still be expanding. Dark matter will still be invisible. Black holes will still hold their secrets. The questions will wait. They've waited billions of years. They can wait through your sleep. They can wait through 1,000 sleeps, 10,000, a lifetime of sleeps. There is no urgency, no deadline. The mysteries are patient, and so can you be. Your breath is very slow now. so slow you might not even notice it. Just a gentle rise and fall, barely perceptible, like waves on a calm sea. Small, rhythmic, peaceful, and your body is heavy, sinking into whatever surface supports you, every part of you resting, every muscle released, nothing to hold up, nothing to maintain, just gravity, gentle and constant, pulling softly, reminding you that you can let go, that you are supported, that you can trust the earth to hold you, and around you, silence, or perhaps soft sounds, but nothing demanding attention, nothing requiring response, just the ambient presence of the world continuing, patient, ongoing, indifferent to whether you're awake or asleep. The world will continue without your attention, without your awareness. It has before. It will again. This is comforting. You don't need to maintain anything. Don't need to hold anything together. Everything will be fine. Tomorrow will come, whether you're thinking about it or not. The sun will rise, the universe will expand, the mysteries will remain mysterious, all of it continuing, all of it ongoing. And you can rest in that continuity, can release yourself into it, can trust that when you wake, whenever you wake, everything will still be here. Changed, perhaps, slightly different, as everything always is, but fundamentally the same, still here, still ongoing, still part of the great, mysterious unfolding. You are safe. You are held. You are part of something so much larger than yourself that your individual concerns, your individual thoughts, your individual awareness can fade without consequence. The universe doesn't need you to be awake, doesn't need you to be conscious. It continues regardless. And this is a gift, a release, permission to let go. So let go now, if you haven't already. If you're still holding on to anything, any thought, any awareness, any sense that you need to remain present, let it go, let it fade, let it drift away like smoke on a breeze. There's nothing left to do, nothing left to think, nothing left to wonder. Just rest now, just sleep, just the gentle, inevitable release into darkness, into quiet, into peace, into the mystery of sleep itself. And if you're still here, still aware, still listening, that's fine too. Sleep will come when it comes. You can't force it, can't demand it, can only wait, can only allow. And in the waiting, there is rest. Even without sleep, there is rest. The body lying still, the breath slow and steady, the mind quiet or quieter than before. This is enough. This is valuable. This is what you need right now. Sleep or no sleep. Rest is happening. Recovery is happening. The invisible processes are beginning their work. And eventually, without your noticing, without a clear moment of transition, awareness will fade. Thoughts will dissolve, and you'll be asleep. Or perhaps you already are. Perhaps these words are reaching you in dreams. Perhaps your consciousness has already released its grip on waking reality. There's no way to know for certain. No clear line between waking and sleeping. just a gradual transition, a slow fading, a gentle dissolution. And wherever you are in that transition, it's exactly right, exactly where you're supposed to be. The mysteries of the universe surround you. Dark matter, dark energy, black holes, time, consciousness, existence itself. All of it swirling in the darkness, all of it present, all of it mysterious. And you are part of that mystery, not separate from it, not outside looking in, but inside, woven into the fabric, one thread among countless others. Rest now in that recognition, in that belonging, in that connection to everything. Let the universe hold you. Let the darkness be gentle. Let sleep come when it's ready. And know that whatever happens tonight, however you rest, however you sleep, it is enough. You are enough, exactly as you are, exactly where you are, part of the great mystery, part of the endless unfolding. Rest now, sleep now, be now, here, in the quiet, in the dark, in the peace of not knowing. Let the mysteries remain mysterious. Let the questions remain unanswered. Let everything remain exactly as it is. And simply, gently, softly, drift. Drift into whatever comes next. Drift into rest. Drift into sleep. Drift into the quiet mystery of existence itself. There is something profound in accepting that we don't know. For most of human history, the unknown was terrifying. The darkness held dangers. The unexplored was threatening. Mystery meant vulnerability. And so we told stories, created myths, invented explanations. Not because they were true, but because they made the unknown feel manageable, less frightening. Science changed this, not by eliminating mystery, but by embracing it, by saying, we don't know yet, and that's acceptable. That's where we begin. Every scientific discovery starts with uncertainty, with a question, with the recognition that something is not yet understood. And then comes observation, careful measurement, testing, the slow accumulation of evidence, building understanding piece by piece, not leaping to conclusions, not inventing answers, but patiently, methodically, following where the evidence leads. Sometimes this process takes years, decades, centuries. Some questions remain open for generations before enough evidence accumulates to answer them. And some questions may never be answered. Some mysteries may be too deep, too fundamental, beyond the reach of any method we can devise. But this doesn't diminish the value of asking, of wondering, of sitting with uncertainty and being comfortable there. Because wonder is its own reward. Curiosity is its own justification. The act of questioning, of seeking, of exploring is meaningful even when answers remain elusive. And tonight, as you rest here in the darkness, you can carry this recognition that it's okay not to know. That mystery is not a problem to be solved, but a feature of existence, a reminder of how vast and strange reality truly is. You don't need to understand consciousness to experience it. Don't need to explain time to move through it. Don't need to solve the origins of the universe to exist within it. You can simply be present, aware, part of the great unfolding, part of the mystery itself. And in this acceptance, there is deep peace. Your body has been resting for a while now. Perhaps you've noticed how different it feels, how quiet, how still, how removed from the urgency and tension of the day. This is the body in rest. This is what it feels like when nothing is demanded, when no action is required, when you can simply exist without purpose or goal. It's a rare state in modern life. So much of our time is spent doing, accomplishing, moving toward objectives. Even relaxation often has goals. Even rest can become something to achieve. But right now, there is no achievement, no destination, nothing to accomplish. You're not trying to fall asleep. You're not trying to stay awake. You're not trying to think or not think. You're simply here, present, in this moment, in this breath, in this gentle, directionless awareness. And this is enough. This is complete in itself. Whether sleep comes or doesn't come, whether thoughts continue or fade, whether you remember any of this tomorrow or not, right now, in this moment, everything is exactly as it should be. The universe has been unfolding for nearly 14 billion years. Stars have been born and died. Galaxies have formed and collided. Planets have emerged from dust. Life has appeared, evolved, spread across at least one world and perhaps many others. All of this happened without plan, without blueprint, without anyone directing it. The universe simply unfolds according to its nature, following physical laws, responding to conditions, creating complexity from simplicity, order from chaos, consciousness from matter, and you are here, the result of all that unfolding, the descendant of an unbroken chain of ancestors stretching back 4 billion years, the inheritor of atoms forged in stars that died before the sun was born. You carry the entire history of the cosmos in your body, in your bones, in the electrical signals firing through your neurons, in the oxygen you breathe and the carbon that forms your cells. You are the universe looking at itself, thinking about itself, wondering about itself. And right now, you are the universe resting, letting go, preparing to sleep. This too is part of the cosmic story. This quiet moment, this gentle fading, this release from waking consciousness. Stars rest between fusion reactions. Planets rest between geological epochs. Life rests between periods of growth and activity. Everything cycles. Everything alternates. Activity and rest. Waking and sleeping. Being and letting go. And you are following that ancient rhythm now. The same rhythm that has pulsed through reality since the beginning. The same pattern that connects you to everything that has ever existed. Rest is not withdrawal from life. It is part of life, essential, fundamental, as important as any activity, any achievement, any moment of waking consciousness. And sleep, when it comes, is not absence, not emptiness, not less than waking. It is its own state, its own experience, even if not remembered, even if consciousness fades completely. Something continues. The body continues, breathing, heartbeat, blood flowing, cells dividing, neurons firing in dreams or in the deep restorative silence of dreamless sleep. Life continues. Even when awareness pauses, even when you disappear from your own experience. And this is perhaps the deepest mystery of all, that you can vanish, can cease to exist from your own perspective, and yet continue and return, night after night, year after year, a lifetime of these small deaths and rebirths. But these are just thoughts now, just words, and they're beginning to fade, becoming less important, less substantial, like fog burning off in morning sun. There's no need to hold on to them, no need to remember, no need to understand. Just let them go. Let everything go. Let the last threads of waking awareness gently release. Breath, just breath, slow and steady. Not thinking about breathing, just breathing. The body knowing what to do, doing it without instruction, without awareness. And maybe awareness is fading too. Maybe it's already faded. Maybe these words are reaching you through layers of sleep, through the thin boundary between waking and dreaming. Or maybe you're still here, still present, still listening. And that's fine. That's perfectly acceptable. Sleep comes when it comes. You can't control it, can't force it, can only wait, can only rest. And you are resting. Even if sleep hasn't arrived yet, even if thoughts still drift through occasionally, even if awareness still flickers, you are resting, and that is enough. The mysteries will wait. The universe will wait. Everything will wait. Tomorrow is not here yet. Yesterday is gone. There is only now, only this moment, only this breath, only this gentle darkness. And in this darkness, there is no fear, no anxiety, no concern, just peaceful absence, just quiet emptiness, just the simple fact of being here, of existing, of breathing in the dark. You don't need to be anyone right now. Don't need to do anything. Don't need to think or feel or experience anything in particular. You can just be, undefined, unstructured, pure presence, pure awareness. Or not even that, just being. And if that being fades into sleep, into unconsciousness, into the complete absence of experience, that's natural, that's right, that's what should happen. Let it happen. Don't resist. Don't try to stay aware. Don't try to notice the moment of falling asleep. Just let go. Completely. Finally. Absolutely. Let the universe carry you. Let the ancient rhythms take over. Let sleep come in its own time, in its own way. And know that whatever happens, however you rest tonight, it is exactly right, exactly what you need, exactly where you're supposed to be. You are part of the mystery, part of the cosmos, part of the great unfolding. And right now, the unfolding is taking you toward sleep, toward rest, toward the deep, restorative silence where consciousness fades and the body does its invisible work. Go there now, if you haven't already. If you're still holding on to any awareness, any thought, any sense of self, release it. Let it go. Let it dissolve into the darkness. Just darkness. Just silence. Just peace. Nothing more needed. Nothing more required. Just this. Just now. Just rest. Sleep whenever you're ready. However you're ready. In whatever way feels natural. The universe has waited 14 billion years. It can wait for you. It can hold you. It can carry you into sleep. And when you wake, whenever you wake, the mysteries will still be there, still waiting, still unanswered. But right now, there is only this, only quiet, only rest, only the gentle dissolution of awareness into sleep. Let it come, let it be, let it carry you. Sleep now, rest now, be now, in the darkness, in the quiet, in the infinite, mysterious, beautiful unfolding of existence. Sleep, rest, peace, just sleep. And if you're still here, still aware in some small way, know that it's okay. Sleep will find you, eventually, when the time is right. Until then, just rest, just breathe, just be. The mysteries of space surround you. Dark matter invisible. Dark energy pushing. Black holes holding secrets. Stars being born and dying. Galaxies spinning through the void. All of it continuing. All of it ongoing. All of it mysterious and beautiful and vast beyond comprehension. And you are part of it. Small but connected. Brief but meaningful. One moment in an endless unfolding. Rest in that. Sleep in that. Be held by that. And let everything else, everything, fade away into the quiet, the dark, the peace. Sleep.